In example 2, we apply integration to a simple economic problem. We have a marginal revenue function, 100 minus 3q squared, and we want to determine total revenue and the demand function, more precisely the inverse demand function. Marginal revenue is equal to the first derivative of total revenue with respect to q. That's equal to 100 minus 3q squared. Total revenue then is the integral of marginal revenue dq. It's the integral of 100 minus 3q squared dq. We can simplify that. Do we use our difference rule and take the constant outside the integral? Now we can apply our inverse power rules. So we've got a constant there, so that will be 100q minus 3 times, well, that will be q2 plus 1. That's equal to 3, so we'll divide by 3, and then plus c, equal to 100 q minus q cubed plus c. We know that total revenue is equal to price as a function of quantity times quantity. That implies that total revenue is equal to 0 when q equals 0. That means that implies that c is equal to 0. Therefore, total revenue is equal to 100q minus q cubed. We've been able to eliminate the constant of integration. As we saw before, total revenue is equal to price as a function of quantity times quantity. This is our inverse demand function. So price as a function of quantity is equal to inverse demand function is equal to total revenue divided by quantity. So that's 100q minus q cubed on q, and it's equal to 100 minus q squared. So we found both the total revenue function and the inverse demand function.